This is an example of a discrete uniform distribution. Discrete uniform distribution is a distribution which is discrete and has a set of outcomes where the probability of all outcomes are equal. Two perfect examples are flipping a coin or rolling a dice. Let's stay with rolling a dice. Rolling a dice has 6 discrete outcomes and probability of all of them are equal, and it is 1 divided by 6. 1, 2, 3, 4, 5, 6, and equal to 1 divided by 6, and lock it. So that is x, and that is f of x. What is the average of this distribution? Equal to some product of x values multiplied by their probabilities. Or because all probabilities are equal, I can simply type average. The same thing. And because the probabilities are equal and the trend is linear, 1, 2, 3, 4, 5, I can also say largest value plus smallest value divided by 2. What about standard deviation? As we have explained earlier, variance is each random variable minus average square, and then we need to multiply them by their probabilities, equal to the random variable minus its average, and lock it, square it, and then copy it down. And then we multiply each value by its corresponding probability, and that is the variance, and the standard deviation is square root of variance. Given the progress in dynamic arrays for variance, I could have done something else too. I could have said equal to these probabilities multiplied by these values, and that creates a array with 6 elements, so I cannot enter it because under it I don't have enough space for that array to be printed out, but I don't need to print out that. I just go here, sum of multiplication of those numbers by each other, and that is another way by using dynamic arrays. I can do one other thing to compute standard deviation, and that is simply equal to standard deviation, but I cannot click on standard deviation of sample. That is what we have done up to now when we are dealing with a sample, but this is not a sample, it is the population. And because all probabilities are equal, I don't need to be worried about probabilities. Enter, and that will give me the same number. If you have forgotten what was there before, undo, undo, redo, redo. So now we know how to compute average and the standard deviation of discrete uniform distributions. And indeed, we knew it before because we did it for situations when probability of outcomes were not equal to each other's, and this is a special case of that one where all probabilities are equal to each other's. Now let's draw this probability. I'll go here, I mark this, insert, chart, and I click on this. Oh, unfortunately, 1, 2, 3, 4, 5, 6 are the same as those things. Otherwise, I need to select the data and change this horizontal axis. Here, I can just click equal to For example, I can click on this if I want. Enter, and that will go into my title. We will do something better than that. So I have drawing of the distribution. I can also come here, equal to, if, and if this value is greater than or equal to this lower limit that I entered over there and lock it, comma, this value is less than or equal to this upper limit, and I lock it. If that is the case, if that and is correct, then type this one. If it is between those two numbers, type that one. Otherwise, type nothing. And then if I copy down, if I want a probability between 2 and 3, if I can enter it, I can see the figure and I can see those probabilities. 2 and 4, less than or equal to 1, less than or equal to 1. Between 1 and 4, between 4 and 6, cumulative probability, this one is 0.167. This one is equal to the previous one plus this one. And then when I go up, I'll reach 1. Now let's talk about a couple of probabilities. Probability of x equal to 3 and 3. Of course, that probability is 0.167. Here is the formula that I have typed over there. Enter. Equal to, and I click on this, enter. So probability of x equal to 3 is this. Probability of x being less than 3. Probability of x being less than 3, it is from 1, but it does not include 3 because it says less than 3. So that is this probability. And if we add these two numbers together, equal to summation of these two numbers, that is that probability. Now, probability of x less than or equal to 3. Less than or equal to 3. That's it. These three numbers, and that is summation of those three numbers. X greater than 3. X greater than 3 is indeed 1 minus x less than or equal to 3. I have this probability equal to 1 minus summation of these 3. That is probability of x greater than 3. Or I can just go here, equal to summation of these 3. Probability of x greater than or equal to 3. Equal to greater than or equal to 3 summation of 3, 4, 5, 6. Which is also equal to 1 minus x less than or equal to 2. Summation of 2 gives me the same thing. X not equal to 3. Not equal to 3. Equal to 1 minus 3. That is probability of x not equal to 3. Probability of x less than or equal to 3, greater than or equal to 2, 3, and 2 equal to summation of probability of 2 plus probability of 3. Probability of x less than 3 and greater than 2, that probability is 0 because There is nothing between 2 and 3. If we don't want it to be 3 but less than 3, and we don't want it to be 2 but greater than 2, that probability is 0. Thank you very much for attending this session. Now, suppose this dice, instead of 6 sides, it has 6 billion sides, or 6 billion sides. In that case, 1 should be divided by a very large number. That distribution is continuous uniform distribution, and indeed what we recognize it as uniform distribution. And in that case, probability of x being equal to something is equal to 0. That would be my next short lecture.